All right, section 3.3, a polygon is a closed plane figure made up of 3 or more line segments that intersect only at their endpoints. Closed plane means there's no open ends. All the segments connect. There are at least 3 segments because you can't have a 2-sided polygon because either the 2 lines don't connect, or if they do connect, they need a 3rd line to connect them now. So the smallest sided polygon you can have has 3 sides. And what do we call a 3-sided polygon? Owen? A triangle. Yeah. Which I always thought was weird. Triangle. Why not trilateral? Does it have 3 sides? And 3 sides, 3 angles. I guess you could say either one. Polygons all have line segments. Only line segments. So they all have straight edges, no curved edges. So a circle or any circular shape is not a polygon. Also, they only intersect at their endpoints, not at their midpoints. So this is 2 polygons, not 1. You can't say, oh, well, this line intersects right there. Nope, right there. That causes it to not be a polygon and split it into 2 polygons. It's just 2 triangles, okay? So any curved sided shape is not going to be a polygon. A polygon is convex when every line segment connecting any 2 vertices lies entirely outside the polygon. And a polygon is concave when at least 1 line segment connecting any 2 vertices lies inside the polygon. Almost every polygon you've ever seen in your life has been convex. Okay, squares, triangles. Well, I'm not going to give away the other shapes because I'm going to ask about them later. Okay, but all these other polygons usually wrap around the shape. Okay, whereas a concave means you're going to have side lengths that go back into the shape, like this one here. So this part right here, the fact that this polygon, which is still a polygon, has sides that dip back into the shape instead of always having sides that go out of the shape, that makes it concave. Actually forms a bit of a cave. You can remember that. It's not that big of a deal. Because all the theorems we're going to look at they work for convex and concave polygons. They don't discriminate against one or the other, right? So convex, concave, as long as you know the difference between what a concave looks like, all of our formulas, all of our theorems are going to work out. So what we're going to do today is we're going to use triangles to find the sum of the interior angle measures of each of these polygons, starting with the lowest sided polygon you can have. What do we call this again, Owen? A triangle. So this is a triangle. Go ahead and write triangle. I'm going to try to use the same colors because I'm OCD like that. And how many sides are on a triangle? How many sides are on a triangle? Oh, thank you. I was going to say, we're going to be here a while. All right, the number of triangles within that triangle. What? How many triangles can you draw within that triangle? Just one. Only one triangle. So the sum of its interior angles is 180 degrees. Lizzie. Ah, okay. I'm glad you asked. So when I say the number of triangles, what I'm saying is if you connect one of the vertices to any of the other non-adjacent vertices, how many triangles does it make? Well, for this triangle, this is an adjacent vertex and this is an adjacent vertex, and those are the only 2 other vertices. So you can't make any other triangles. There's just one. You're looking at it. Okay? Because each triangle has 180 degrees, we already know that. That means the triangle is going to have 180 degrees. Now let's move into this shape, which has 4 sides. What do we call a 4-sided shape? Sky? A quadrilateral. That's exactly what we're going to put here. Quadrilateral. Again, why is it not called a trilateral instead of a triangle? I don't know. Quadrilateral. That one actually has the word lateral in it. Number of sides, 4. Number of triangles, let's draw them. Pick one of the vertices, it does not matter which one, and put a circle around it. connect lines to all the non-adjacent vertices. Now you can connect the adjacent vertices if you want to, but they already are connected, so that's just a waste of time. There's only one non-adjacent vertex, and if you draw a line connecting it to back to the vertex you just circled, that can actually split this into two triangles. Now, depending on which vertex you circled, your two triangles are going to look different, but it doesn't matter because each of them have 180 degrees. What's 180 times 2? Sky? 360. Every single quadrilateral in existence has two triangles, therefore 360 degrees. And again, you knew that because when you think of a quadrilateral, most people probably think of squares or rectangles, which has 4 right angles, and 90 times 4 is 360. It's true for all quadrilaterals, though not just rectangles. Okay, next polygon we're looking at has 5 sides. What do you call a 5-sided polygon, Xander? It's a pentagon. It's a very famous looking pentagon in Washington, D.C. It's a pentagon, has 5 sides. Circle one of the vertices. Draw the lines that connect the non-adjacent vertices. Again, I've already got the adjacent vertices connected, so that's not going to do a thing. But if I connect the non-adjacent vertices, that means every pentagon can be split into 3 triangles, regardless of what the triangles look like. Your triangles probably look different from mine. They would look different from mine if you choose a different vertex than I did. Xander.
So if you started with the angle in the 3rd triangle, the one that's not on the line, and then went to like the 2nd triangle, one on the top, wouldn't that make more triangles?
You can only choose one vertex. You can't choose multiple ones.
Oh, okay.
So you can't have lines intersecting and going different ways. Okay. All right. The number of triangles that made was 3. And what's 180 times 3? Lucy? 540 degrees. Every pentagon has 540 degrees. Next up is this shape. Has 6 sides. Christian. It's called a hexagon. Number of triangles. Anyone want to take a guess? One more than the last one? 4, right? So choose one of the vertices. You can draw the lines. You can see that you can actually split this into 4 triangles. 1, 2, 3, 4. Every triangle is 180 degrees. 180 times 4 is? Lizzie? Say it again. That's, nope, there should be 4 triangles. That's right, 720 degrees. Every hexagon in existence has 720 degrees, regardless of whether they look like this one or other hexagons that you may have seen. Also, it doesn't matter if they're concave or convex, although all of these are concave. Oh, sorry, convex, no caves. I don't see any caves here. The next one has 7 sides, Christian. Heptagon. Christian's using his website over there to look up these names, aren't you, Christian? Yeah, I thought so. A 7-sided polygon is called a heptagon. H-E-P-T, agon. Now, gon means sided. So heptagon means 7-sided, just like pentagon meant 5-sided.
What's quadrilateral, not a quadrilateral?
Yeah, a quadgon, I don't know. All I know is I wasn't around when they were naming these. I'm glad I wasn't because there wasn't such a thing as internet, or in your case, Carter, Fortnite. So they had nothing better to do. This was it. I mean,
I would have fought for it.
you joined the Pythagorean cult, or you know, you died out in the snow somewhere. I don't know. You know what I mean?
No.
I don't know. I'm just looking outside. Looks like snow.
Or died in the.
They would have been in Greece somewhere, so it would have been somewhat.
Or you got thrown in the
temperate
water,
climate,
like that one.
Probably pretty nice. Or the one guy, yeah. Number of sides on a heptagon, 7. Number of triangles it has. Anyone want to guess without me drawing them? Carson? There's 5. And 5 times 180? Carson? 900 degrees. Every heptagon has 900 degrees. Next up, we have an 8-sided polygon. What is an 8-sided polygon called, Lizzie? It's called an octagon. All you people that like watching the UFC, they fight in the octagon. Also, if you like stopping at stop signs like I don't, you like looking at octagons. It has 8 sides. Number of triangles, anyone want to take a guess? Sander?
6.
6. Sander, what's 6 times 180?
1080.
1080 degrees in every octagon. All right, so you're going to have to memorize these. Well, not really, because there's a formula that makes it much easier. So in a 3-sided shape, a triangle, we said that every triangle was just one triangle and it was 180 degrees. Do you remember how many triangles were in a quadrilateral? 2? Okay. If you don't believe me, we drew them right there. There were 2. So as the number of sides increase by 1, so does the number of quadrilaterals. Shane, could you get that door for me, please? I said that. I'm not even sure what I just said on the video is not being recording here. So I'll have to go back and see what I said. As the number of sides on the shape increase, the number of triangles, I think I said quadrilateral, the number of triangles inside the shape increases by 1. So we're always adding 180 degrees. There were 4 triangles inside of the hexagon, and that's where we got our next one, which was 720 degrees. There are 5 triangles inside of a heptagon, and that's 900 degrees. There are, you said 1080, right? 6 triangles is 1000. Yeah, that's right. I'm staring at it. It's right on the top of my screen here. 1080 degrees in an octagon. Okay. So what then if I jump all the way to a 24gon, which I'm sure it has a name, but I'm not even going to look for it. Okay. Well, what's the relationship that you see between the number of sides that a shape has and the number of triangles inside of that shape? Jacoby? It's exactly right. It's the number of sides minus 2. Why minus 2? Because on every shape, if let's say I choose this one right here and I draw my lines, there are already 2 vertices that are already connected, right? So I'm going to have the number of triangles is going to be 1, 2, 3, 4, 5, because I've already got 2 of the vertices connected. So take the number of sides or vertices, it's the same number, subtract 2, S minus 2, oh no, N minus 2. N for number of sides, S for the sum of their angles. If you take the number of sides that shape has, subtract 2, and times by 180, you will see how many total degrees are inside of that shape. So we are beyond just the 180 degrees of a triangle. We are now looking at any number sided polygon. So in a dodecagon, which has how many sides? Xander?
12.
12. We mentioned a dodecahedron, sorry, when we talked about our 12-sided die earlier, right? So a dodecagon has 12 sides. By the way, a decagon has 10. An undecagon has 11, if you're wondering. 9 is a nonagon. Nonagon, yeah. So 12 triangles 10 times 180 is 1,800 degrees. That simple. What's it? What is the name of a 24gon? Icosatetron.
It's pronounced like
Uh,
Look at the second one. Yeah, it's probably
I feel like I'm in a Transformers movie. And
it's like icosahedron.
The
That-
Terragons.
it's,
I don't know, that looks like.
is it? Are they? What is this? Are they Decepticons? Is that what it is? Decepticons? No. A 17-sided polygon obviously has 17 sides. It's going to have 15 triangles then. And can someone tell me what 15 times 180 is?
17.
No, seriously, that's what people who have less time than the people who actually sit there and write the names for them, they'll just say 17 gone. And that means that has 17 sides. And that's a mathematical thing because we are lazy, but some people have more time than others. So
I'm just writing.
what's 15 times 180?
2,700.
Are you questioning his math?
Yeah.
15 times 180?
Oh, yeah.
I think it's right. Okay.
Yeah.
All right. So for polygons whose names you have not learned, like a 17gon, you can just use the phrase ngon, where n is the number of sides. For example, a 15gon is a 15-sided polygon. All right. So moving into this next part, find the sum of the interior angle measures of this green polygon. That is a spider web, and there's a lot of geometry inside of a spider web, a lot of symmetry as well. How many sides does this polygon have on this spider's web? 7. What do we call a 7-sided polygon? You just said it. Heptagon. Yeah, not important for you to know for the homework, but interesting. And so you take the number of sides it has, you subtract 2, you times by 180. Now, if you don't want to write 7 minus 2 times 180, at least show me that you're doing 5 times 180 on your work papers tonight. What is 5 times 180? 900 degrees in this heptagon. Number 5, honeycombs, also geometric. They're all hexagons. They all have 6 sides. So take 6 minus 2 and times by 180. Jimmy, what's 6 minus 2 times 180? 720 degrees in every hexagon. All right, don't forget to label. All right, so now we're going to get the math involved back again, all right? So now I've got all these angle measurements, and no, I'm not going to force you to write an equation from scratch here, but I am going to force you to write an equation, at least with your terms combined. So what your equation would need to look like here is x plus, and then everything else. So take a moment, and I want you to add all the other sides, all the other angles of this polygon together. And hopefully you're all doing it, because I'm gonna guess we'll need more than one person to confirm this. $778. Give me a second on that. Second, third. Okay, we're getting 778. So what your equation would look like is x plus 778 equals, and then this is where my lesson from today kicks in. How many sides does this shape have? Xander?
7.
7. 7 minus 2 times 180, we just did that a moment ago, was 900 degrees. So we're going to set this equation equal to 900. Does everyone see where the 900 came from?
Yes.
This is 7 sides. 7-sided shapes like the spider web have 900 degrees. And so we set it equal to 900. So I don't care all the other work as long as you have this and then you have it solved. So we subtract, and what is 900 minus 778, Sky? 122. It says find the value of x, so you don't have to put the degree symbol if you don't want to. Okay, example B, how many sides are on this shape? Carson? Yes, 5. It is a pentagon, although it doesn't look like a pentagon, it is a pentagon, right? So pentagons have 5 sides. So 5 minus 2 times 180. Carson, how many degrees are in every pentagon? 540. So my equation is going to be equal to 540. Now go ahead and combine your like terms. I'm not evil. I'm not going to make you write it all out every single time. Combine your like terms though. 145 and 145 makes 290. 290 and 110 makes 400. So I've got 4x plus 400. See, I'm not evil, but I'm getting there. I don't have my master's yet. I'm not like Gru. Okay. Isn't he like an evil? Doesn't he have? Oh, never mind. Okay. So I call it. That's what I thought. Thank you. Look at me like I'm crazy. Watch Despicable Me. You'll know what I'm talking about.
You could do that. I will do it.
Subtract 400 from both sides. 540 minus 400 is 140. Divide by 4. Garrett, what's 140 divided by 4? Calculators help. Unless you have it memorized. I don't have my 4s memorized up to 140. I also don't think, no, actually 4 does go into 140. You could split it into how many times does it go into 100? And how many times does it go into 40? I just want Garrett to say it. 35. All right. So x equals 35. This seems like a good place to stop because the bell rang. So I'm sure it's important.
There will be no Paul print meeting after school today.
Okay.
No Paul print
Now,
meeting.
I need to be clear. There's still more to the notes. I told you this is a long section of notes. We'll finish them tomorrow. Friday's lesson, I don't believe it was as long. So as of right now, I think you can probably get 60% of the homework just based on what we did right now. Okay? You guys are dismissed. Have a great day.
Those that I actually
Drink water. That's right. Just keep hydrated. All right, so in a regular polygon, all the sides and all of the interior angles are congruent. In a regular polygon, all the sides and all the interior angles are congruent. All the angles are congruent. Most of the polygons you guys imagine when you think of a pentagon, when you think of a hexagon, when you think of an octagon, and those shapes we talked about, most of the time you're typically probably thinking of a regular polygon where all the sides and all the angles are congruent. So what would you call a regular quadrilateral? Can you think of a quadrilateral in which all the sides are congruent and all the angles are congruent, Julia? A square. Yeah, that's a regular quadrilateral. What about a regular triangle? What would you call a regular triangle? Owen? Equiangular, equilateral, right? All 60-degree angles and all the sides are the same. Now, when you think of a pentagon, some of you might think of a pentagon that looks like this. Oops. Like a house or like home plate, depending on what you think of. That's not a regular pentagon though, because you've got right angles or what should be right angles up there on the top, and then you've got these obtuse angles down below. We said yesterday that all pentagons add up to 900. No, we said 540 degrees, right? I think it was 540, right? Okay, but a regular pentagon is actually going to look like the one you see in Washington, D.C., where all the angles and all the sides are the same length. So it's going to look like this. You get the idea. And actually, if you take, for example, like a starfish and you trace a line connecting each of the spots on a starfish or the legs on a starfish, I think they're called legs, fins, I don't know what they are. It would look like a regular pentagon like that. So these regular shapes are some that we actually see in nature. And here's one that's actually you can see in space using a very powerful telescope. It says a cloud system discovered on Saturn is in the approximate shape of a regular hexagon. You can see here the regular hexagon, the approximate shape of one. Okay. It says find the measure of each interior angle on the hexagon. So if I'm going to find the measure of each interior angle, and by the way, it says measure, so I'm going to have to label it with the degree symbol again. I'm going to need to know how many total degrees are in this hexagon. And so remember, I know a hexagon has how many sides? 6. Okay, so take 6, subtract 2 times by 180. And Emerson, how many degrees is that going to give us inside all the angles? Add up all the angles on the hexagon or inside of the hexagon. That's right, 720 degrees. All right, yeah, get those calculators out. Now, if it's a regular hexagon, that means each of the angles are congruent. How am I going to find out which each one would be, Carter?
Once you divide it by 6.
That's right. If each of the angles are congruent, I can split that 720 degrees 6 ways. Carter, what's 720 divided by 6?
120.
So each angle on that regular hexagon is going to not add up to, each angle is going to be equal to 120 degrees. Okay. So again, if they tell you the shape is regular, you can actually find out what each of the angle degrees are going to be. Now, if the shape is irregular or not regular, then you wouldn't be able to, because some angles would be larger and you wouldn't be able to tell unless they gave you something like this and you could create an equation from this information. But if the shape is regular, just divide it by however many sides it has, because however many sides it has is also how many angles it's going to have. What you don't want to divide by is 4. That's the number of triangles inside. That 4 times 180 is how we tell how many total degrees it has, but we still want to divide it by 6. All right, the last part of our notes, the sum of the exterior angle measures of any convex polygon is 360 degrees. The polygon has to be convex, not concave. It's not true with the interior angles, but the exterior angles, that has to be true. It's got to be convex, which all of them will be on tonight's homework when you're doing the exterior angles. And so W plus X plus Y plus Z would have to add up to 360. What's interesting is it's not just quadrilaterals or triangles. It's pentagons, hexagons, heptagons, octagons, nonagons, decagons, undecagons, dodecagons, and anything after that. All the exterior angles, even though there's more exterior angles for each shape, they always add up to 360. It doesn't matter how many sides it has. That will change the interior angle sum, but not the exterior angle sum. Okay. So as you're looking here, I want you to look at these two shapes. You got a triangle, you got a quadrilateral. Triangle has 3 exterior angles. The quadrilateral has 4 exterior angles. Even though it's got more exterior angles, the quadrilateral does, those exterior angles are going to be smaller. So here's another example. If I can draw an octagon, and then I extend all those lines, oops, I wouldn't go that way. Let's go this way. It has 8 exterior angles, but look at all those exterior angles. Are any of them obtuse? No. The more sides that you add to a shape, it will increase the interior angles because all of them are obtuse and inside. But, and I drew a regular octagon, by the way. But all the exterior angles get smaller and smaller and smaller. That's why they'll always add up to 360. Whether it's a triangle, pentagon, octagon, doesn't matter. The more exterior angles it has, the smaller they're going to be. By the way, if the interior angles are all the same, if it's a regular shape, all the exterior angles will be the same as well. Because those exterior angles, like the ones I drew, will all be the same size. Okay, so let's go with example A. We're going to create an equation here. And I'm okay if you go ahead and combine your like terms. Does anyone want to tell us what the equation would look like before we solve? After you combine your like terms? Sander?
360 minus 260.
Nope. It should be equal to 360. So tell me what you would set it 360 equal to.
X plus 268.
X plus 268. Okay. So Xander has combined his like terms, which are going to be the 3 angles that we do have. Add it with X. So this is where I want you to start when you guys are doing your work paper and you're writing this on your quiz and test. I want you to start with this equation, unless you want to write the whole thing out, which you're welcome to write all that out. But you can start with the combined sum of 268. And then when you subtract that over, Xander, what is that going to give you for X?
92.
X is 92. Okay. Now it says find the measures of all the exterior angles. The only one we were missing was angle X. How do I need to label that, Xander? Degrees. Yeah, if it says solve for X, X equals 92 is fine. If it says find the angle measurements, we do have to label with the degree symbol. And that's definitely going to come into play on this next one. What equation could I write to find Z so I can find the measure of these exterior angles. Maddox. Okay. So if you combine your terms already, which I'm okay with you doing that as like a pre-step, right? We have 2z, 21, 24, and 26 adds up to 150. What's the next step that I would do here, Maddox? I'll go ahead and let you solve this one. Okay. All right. Z equals 1 and 5. Now, again, because it said find the measure of each interior or each exterior angle, we know that Z is 105 degrees, and we're going to put a degree symbol next to that. And then we have Z plus 26. Sky, what would Z plus 26 be? Okay, so we're going to call this a 131 degree angle. And then, of course, you could check your math by adding all those angles, which is just 3 of them here, and making sure you get 360. Here's a pentagon, not a regular pentagon like the one I attempted to draw. This one looks more, again, more like a home plate or a house with a roof. Each of the exterior angles is a little bit smaller, right? Because the more angles you add, the more sides you add, the more angles you add, and more exterior angles you add. And each of them is going to be a little bit smaller because you still have to make it add up to 360. So what's the equation I could start with here, Christian? All right. You can combine your 3 right angles together to get 270. We know x plus x is 2x. Christian, go ahead and tell me what the next step would be. Okay. And when you subtract 270 from 360, what would that give you? 90. And divide by 2. There we go. So each of these would be 45 degrees. If you just want to put a degree symbol next to that, that's fine because each of them was x. The only reason I had to do this one differently is because that was z plus 26. So I had to put the 131 down there. So each of those exterior angles that were not given are 45 degrees. What is the measure of an exterior angle on a regular 18 gon? What do you think, Lizzie? I haven't heard from you yet today. I want you to tell me what you would do. Say it one more time. 18. Now, why aren't you subtracting 2 and then timesing by 180? I'm just asking. It's not what you did for the other ones. The difference here is that it's asking for an exterior angle, right? So we did a question where we had to find the interior angle. And if we're finding the interior angles, we need to know what the total degrees inside of that shape is. So we can divide by 6. But since all polygons have exterior angles that add up to 360, that saves us a ton of time. And so just take however many sides it has, divide that into 360 because they're all going to add up to 360. And what did you get for 360 divided by 18? 20 degrees. So each interior angle is 20 degrees. Again, that's the difference between interior angles and exterior angles. Interior angles can add up to larger and larger and larger and larger amounts, but all the exterior angles always add up to 360. So if you know that you have 18 sides, divide 360 by 18, and they're going to be really small angles. Be 18, 20 degree angles to get your 360. All right, that's it.